Welcome to our latest video on the topic of comparing strong and weak acids. This video is suitable for GCSE students. By the end of this video lesson, you should be able to explain the meaning of the term acid and be able to explain the difference between strong and weak acids as well as dilute and concentrated acids. You should also be able to understand that both sulfuric acid and ethanoic acid form salts with bases, metals and metal carbonates, and be aware of the similarities and differences in the reactions of strong and weak acids. Finally, you should be able to explain the meaning of the term dehydrating agent and understand that concentrated sulfuric acid acts as a dehydrating agent in its reaction with sugar and hydrated copper 2 sulfate. Now, in our previous lessons, we've learnt that acids are substances that split up into H+ ions when placed in water. We've also learnt that a H+ ion is also called a proton, and this is because hydrogen is the only element in the periodic table that doesn't contain any neutrons. Now, each hydrogen atom contains one proton and one electron, so when you form a H+ ion, you lose that electron, and that's why a H+ ion is simply called a proton. Now, in our previous videos, we've learnt the chemical formula of some common acids. For example, hydrochloric acid is HCl, sulfuric acid is H2SO4, nitric acid is HNO3, and ethanoic acid is CH3COOH. Now, in our previous videos, we've learnt that strong acids, such as hydrochloric acid, sulfuric acid, and nitric acid, totally split up into H+ ions when you put them in water. Now, the more H+ ions in solution, the more acidic a substance is. Now, the equation here shows hydrochloric acid splitting up into H+ ions and Cl- ions. And as the arrow only goes in one direction here, we can assume that hydrochloric acid is a strong acid as it totally splits up into H+ ions when placed in water. Now, a weak acid is a substance that only partially splits up into H+ ions when you put it in water. So I've drawn ethanoic acid here, CH3COOH, and the aqueous sign, AQ, denotes that this is placed in water. And it splits up into H+ ions and ethanoate ions, CH3COO-. And you'll notice that I put a reversible sign because when ethanoic acid splits up into H+ ions and ethanoate ions, the ethanoate ions and the H+ ions can rejoin and form ethanoic acid. Now, the fact that these H+ ions and these ethanoate ions can recombine and form ethanoic acid means that if we look at 1,000 ethanoic acid molecules, only about 4 would be split up into H+ ions at any one time. And that's because the others are just rejoining and forming ethanoic acid. So therefore, for every 1,000 ethanoic acid molecules, we only have about 4 H+ ions. So there's much less H+ ions being produced for a weak acid. And remember, the more H+ ions in solution, the more acidic a substance is. And weak acids have less H+ ions in solution because of the fact that the process of splitting up into H+ ions in the very first place is a reversible process. Now, most of you will be familiar with the term pH, which measures the acidity and alkalinity of a substance. And substances that have a pH of less than 7 are deemed acidic. Now, all the pH scale is measuring is the amount of H+ ions in solution. And the H in pH stands for hydrogen. It's a measure of how much H+ ions there are in solution. And the more H+ ions in solution, the lower pH, and the more acidic a substance is. So what will ultimately decide the pH of a solution and the acidity of an acid will be, first of all, how many acid molecules are present. So in other words, how concentrated is that acid solution? If it's got lots of acid molecules and not much water, we say it's a concentrated acid. And if it's got very few acid molecules and lots of water molecules, we say it's more dilute. Now, the concentration of an acid and the number of acid molecules obviously affects how much H plus there is in solution, as well as the chemical properties of that acid, whether it's a strong acid and totally splits up into H plus ions, or a weak acid and partially splits up into H plus ions. Now, it's also important to know the difference between a dilute acid and a concentrated acid. Now, in a dilute acid, you have a much greater number of water molecules compared to acid molecules in a given volume. And in a concentrated acid, you have the opposite. You have a much greater number of acid molecules compared to water molecules in a given volume. Now, concentration is measured in moles per decimeter cubed. And in later topics, we'll explain how we work out the concentration of a solution. Now, in this video, we're going to be making comparisons between weak acids, such as ethanoic acid, and strong acids, such as sulfuric acid. Now, ethanoic acid is a weak acid as it partially splits up into H plus ions. Sulfuric acid is a strong acid because it totally splits up into H plus ions. Now, both weak acids and strong acids have similarities in their reactions. For example, they will react with bases, they'll react with alkalis, they'll react with metals and metal carbonates to form salts. Now, salts are chemicals made from acids, and in a salt, the hydrogen atoms in the acid are replaced by metal atoms. So, for example, sulfuric acid has a chemical formula H2SO4. When we form the salt, magnesium sulfate, we've replaced the hydrogen in the acid with a metal atom. With ethanoic acid, the chemical formula is CH3COOH. The salt we'd form, if we reacted it with, say, sodium oxide or sodium carbonate, would be sodium ethanoate. And the formula of this would be CH3COONA. Once again, we've replaced the hydrogen in the acid with a metal atom. So it doesn't matter if you have a strong acid or a weak acid, they'll both react with bases, metals and metal carbonates to form salts. For example, if we have an acid and a base, we'll form a salt and water. Remember, a base is a metal oxide or hydroxide, and a soluble base is called an alkali. So if we had sulfuric acid and the base copper oxide, we'd form the salt copper sulfate and water. If we have an acid reacting with a metal, we'll form a salt and hydrogen. Remember that metal must be more reactive than the hydrogen in the acid for a reaction to take place. So if we had ethanoic acid and magnesium, we'd form the salt magnesium ethanoate and hydrogen. Now, if we have an acid and a metal carbonate, we form a salt, carbon dioxide and water. For example, ethanoic acid would react with calcium carbonate to form calcium ethanoate and carbon dioxide and water. Now, even though strong and weak acids have similar reactions to form salts, there are important differences. And what we're going to look at now is an experiment where we're going to add the same mass of magnesium to the same volume of both ethanoic acid and sulfuric acid. Now, in the test tubes here, we have the same volume of acid. On the left, we have ethanoic acid. On the right, we have sulfuric acid. And they're both at the same concentration, which is 1 mole per decimeter cubed. And we're adding the same mass of magnesium. Now, when the magnesium is added to the sulfuric acid, we have more fission, we have a much faster reaction, and more heat is given out. It's more exothermic. Now, you can see already that the magnesium has almost completely reacted with the sulfuric acid. However, the ethanoic acid is still reacting, and you can clearly see the magnesium still here. Now, this is because the sulfuric acid is a strong acid, and a strong acid totally splits up into H plus ions when you put it in water. A weak acid only partially splits up into H plus ions. So in the sulfuric acid, there's more H plus ions available to react with the magnesium. That's why it's a faster reaction and it gives out more heat. Now, if we have a concentrated acid solution, we have a much larger number of acid molecules compared to water molecules. And therefore, we're going to have even more H plus ions in solution. Now, you should remember from studying rates of reaction that increasing the concentration of solutions will often speed up the rate of a reaction because there's more particles, there's more collisions and more successful collisions. Now, in the next section of this video, we're going to focus on concentrated sulfuric acid. Now, concentrated sulfuric acid is extremely corrosive and can cause serious burns. And you'll recognize the hazard symbol for corrosive substances on this slide. Now, it's also classed as a dehydrating agent, and this is because it will remove the elements hydrogen and oxygen in the same proportions as water from substances such as sugar and hydrated blue copper sulfate. So now let's look at the reaction of concentrated sulfuric acid with sugar. So you can see we've added the concentrated sulfuric acid to sugar here, and the sugar is a carbohydrate, which means it's made up of carbon, hydrogen and oxygen. Now, the concentrated sulfuric acid starts reacting with the sugar, and at first the reaction is quite slow. But you'll notice that the sugar starts to lose its white colour, and as the reaction progresses, this sugar will become much darker in colour. So you can see already the white sugar now starts to look an orange and brown colour, and as the reaction progresses it gets darker and darker and darker. And what's happening here is that water is starting to be removed. Now, a carbohydrate is made up of carbon, hydrogen and oxygen. So if you remove water, the hydrogen and oxygen, you're going to be left with solid carbon. Now, carbon is black in colour. So that's why as the concentrated sulfuric acid begins to dehydrate the sugar goes from white in colour to a much darker colour, and eventually it will be black in appearance. Now, the reaction that takes place is exothermic. So the water that is removed will start to be removed as steam. So this beaker is getting hotter and hotter, and eventually the water that's being removed will be seen as water vapour. So you can see now that we can see steam coming off the beaker. This is the water's being removed, and as the reaction progresses, you'll see that solid carbon starts to form in the beaker. Now, as the water is being removed as steam, this gas that's being produced causes the carbon to rise upwards. So it almost looks like the solid carbon is growing. If you focus on the beaker now, you'll see the carbon moving upwards. So the carbon's beginning to rise, and we can clearly see now that the sugar, which was a carbohydrate, has had its water removed, its hydrogen and oxygen removed, and that's why we're ending up with solid carbon. So the reaction is progressing, more and more heat is being produced, it's an exothermic reaction, the water is being removed as steam, and the carbon is rising upwards because it's getting pushed up by the gas that's being produced, the steam. Now if we fast forward a few frames, you can see how much steam is being produced by how far the carbon has risen out of the beaker. So this is a great example of concentrated sulfuric acid acting as a dehydrating agent, removing water, removing hydrogen and oxygen from a carbohydrate such as sugar to leave solid carbon. A second reaction that illustrates concentrated sulfuric acid's ability to dehydrate substances is the reaction of concentrated sulfuric acid with hydrated copper sulfate. Now copper sulfate is blue because the copper ions are surrounded by water molecules. And if we add concentrated sulfuric acid to blue copper sulfate, you'll notice that the blue colour starts to fade and the copper sulfate starts to look white in its appearance. Now this happens because the concentrated sulfuric acid is removing the water from hydrated copper sulfate, and we're left with anhydrous copper sulfate. Now anhydrous means without water, and anhydrous copper sulfate is white in appearance. Now many of you may have made crystals of copper sulfate, and these crystals will be blue, and the water molecules help to form the crystalline structure. So if you add sulfuric acid to crystals of copper sulfate, not only will it lose its colour, it will be crumbly in appearance. Now this is because removing the water causes a breakdown of the crystalline structure, and that's why it will appear crumbly. So now let's test your understanding of what we've learnt in this video with some practice questions. Read through the question, pause the video, have a go at it, and then we'll go for the answers. So question 1 says, explain the difference between A, strong and weak acids, and B, dilute and concentrated acids. Well, a strong acid totally splits up into H plus ions or protons when you put it in water, and weak acids only partially split up into H plus ions or protons. 1 mark if you explained what a strong acid is, and 1 mark if you explained what a weak acid is. And for part B, a dilute acid has a much larger number of water molecules compared to acid molecules in a given volume of liquid. 1 mark if you said that. While a concentrated acid has a much larger number of acid molecules compared to water molecules in a given volume of liquid. 1 mark if you said that. So here's our second practice question. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers. So for question 2, you have to complete the following word equations, and each word equation is worth 1 mark. So we have sulfuric acid here reacting with copper oxide, so the salt that's going to form is going to be a sulfate. Now remember, an acid and a base forms a salt and water. Because it's copper oxide, the salt that we form is going to be copper sulfate. So for question B, we have magnesium and ethanoic acid. Now the salt that would be formed from ethanoic acid would end in ethanoate. So the salt is magnesium ethanoate because it was magnesium and ethanoic acid. And we have a salt forming and hydrogen here. And in C, we have sodium hydroxide and sulfuric acid. So when we have an acid and an alkali, we get a salt and water, and because it's sulfuric acid, the salt will end in sulfate, and because it's sodium hydroxide, it's sodium sulfate. Now for D, we have calcium carbonate and sulfuric acid. Now when you have a metal carbonate reacting with an acid, you form a salt, carbon dioxide and water, so I'm just putting the carbon dioxide in here. Now any salt that's made from sulfuric acid will be a sulfate, and because it's calcium carbonate, the salt formed will be calcium sulfate. And for the last question, we have sodium carbonate reacting with ethanoic acid. So once again, when a metal carbonate reacts with an acid, you form a salt, carbon dioxide and water. So I'm just writing in the carbon dioxide here. And the salt that would form from ethanoic acid would be ethanoate. And as it's sodium carbonate, the salt is sodium ethanoate. And that completes the equation. So there's 1 mark for each correct word equation here, and there's a total of 5 marks available. So here's our next practice question. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers. Now for question 3, you have to write chemical equations for the following reactions. Now before you can write chemical equations, you really need to be able to write word equations. So I'm going to write word equations here first. So sodium hydroxide and sulfuric acid would make the salt sodium sulfate. And because it's an acid and an alkali, you would get sodium sulfate and water. Now to write chemical equations, all I need to do is replace the words with symbols, and I use the charges and ions that are listed on the back of the exam paper. Now sodium hydroxide is made up of Na plus ions and OH minus ions. Because they have the same charge, they cancel each other out, so the formula is NaOH. Sulfuric acid is H2SO4, and I need to learn the formula for that. To work out the formula of sodium sulfate, I need the sodium ion, which is Na+. The sulfate ion is SO4 2-. Now I can either swap the charges over, or I can say how many Na pluses do I need to cancel out one of the SO4 2- ions. The answer would be 2. So that's why the formula is Na2SO4. Now water's formula is H2O. Now the equation's not balanced. I have 2 sodiums on the right, so I need to put a 2 in front of the NaOH, and that would give me 4 hydrogens on the left and only 2 on the right, so I need a 2 in front of the H2O. If you had all the formula correct, you get 1 mark. If it's balanced, you get the 2nd mark. Now for B, we have to write the word equation first. So sodium hydroxide and ethanoic acid forms sodium ethanoate. My other product would be water, because sodium hydroxide is a base and it's a soluble base, it's an alkali, so we form a salt and water. To write the formula of sodium hydroxide, it would be, once again, Na plus OH minus cancels out to form NaOH. Ethanoic acid is CH3COOH. To write the formula for sodium ethanoate, I need the sodium ion and the ethanoate ion. So it would be CH3COO minus and Na plus. They've got the same charges, so they cancel out. So the formula is CH3COONA. And my other product is water. Now this is balanced because I've got 1 sodium on the left, 1 on the right, 1 carbon on the left, 1 on the right, and I've got 5 hydrogens on the left, 5 hydrogens on the right, and 3 oxygens on either side. Now for C, the equation would be magnesium and ethanoic acid forms magnesium ethanoate and hydrogen, because it's a metal and an acid forming a salt and hydrogen. Now when you're writing chemical equations and you want to write the formula for an element, you just use the symbol in the periodic table. So magnesium is an element, so it's Mg. Ethanoic acid is CH3COOH. Hydrogen is an element, so it's H, but it's a gas and it goes on in pairs, so it's H2. And to work out the formula of magnesium ethanoate, I need to find out how many ethanoate ions do I need to cancel one of the magnesium ions. 2. So therefore the formula is CH3COO in brackets 2 Mg. Now to balance the equation, we just need to put a 2 in front of the ethanoic acid. So the equation will be Mg plus 2CH3COOH forms CH3COO in brackets 2 Mg plus H2. Now the brackets are essential here because we need 2 CH3COO 1- ions to cancel out the Mg2+ charge. Now the other thing to point out here is when writing the formula of ethanoates, even though the name has the metal first, so sodium ethanoate, magnesium ethanoate, we write the CH3COO bit first. And that's because we're dealing with an organic acid here. Now for this question, you get 1 mark if all the formula is correct in each equation, and 1 mark if the equation is fully balanced. So here's our last practice question, and this comes in 2 parts, 4A and 4B. So here's 4A, read through the question, pause the video, have a go at it, and then we'll look at question 4B. So here's question 4B. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers of 4A and 4B. So question 4A shows you a diagram of sucrose, sugar, and concentrated sulfuric acid is added to the sucrose, and you end up with a black solid, and it's asking you to explain what is happening here. Well, you get 1 mark if you say sugar is a carbohydrate made up of the elements carbon, hydrogen and oxygen. Now if you say that concentrated sulfuric acid is a dehydrating agent and removes water in the form of steam, you get the 2nd mark. And with the hydrogen and oxygen removed, you get solid black carbon remaining in the beaker, and if you said that, you get the 3rd mark. Now for part B, it says a few drops of concentrated sulfuric acid were added to some crystals of hydrated copper-2 sulfate, and it gives you the formula of this. And it says describe 2 changes in the appearance of the copper-2 sulfate as it's dehydrated. Well, if you said that the blue hydrated copper-2 sulfate would turn white, you get 1 mark. And the clue is in the question here. It says you had crystals of the hydrated copper-2 sulfate. So if you added the concentrated sulfuric acid, in addition to going white, it would turn powdery or crumbly, and it would lose its crystalline appearance. So if you said any of those, you get the 2nd mark. So that concludes this video lesson. So after watching this video, you should now be able to explain the meaning of the term acid and be able to explain the difference between strong and weak acids, as well as dilute and concentrated acids. You should also be able to understand that both sulfuric acid and ethanoic acid form salts with bases, metals and metal carbonates, and be aware of the similarities and differences in the reactions of strong and weak acids. Finally, you should be able to explain the meaning of the term dehydrating agent and understand that concentrated sulfuric acid acts as a dehydrating agent in its reaction with sugar and hydrated copper-2 sulfate. So that concludes this video lesson. So please check out our YouTube channel, Dr. O Chemistry, which has lots of GCSE, AS and A-level videos, and our Twitter site @RadaChemistry.